Hello and welcome to your lesson on thinking scientifically models. What we're going to be looking at in this lesson is models and what they're used to do. So we're going to be looking at the fact that models are used to explain complex systems or phenomena, and the fact that they're not the real thing, but they make the hard easy to understand. So in science, we make use of models to help us understand complex systems or phenomena that are not real, rather they capture the key aspects of whatever it is you're trying to study. So a scientific model is a representation of complex systems or phenomena that has been simplified to make it easier to understand. Now, obviously, it can't be the real thing because then it wouldn't be a model. It would be the real thing. So it always has to be referred to as a representation of some sort. So when we look at some of these models, we can use things like diagrams, graphs, physical models, equations, and simulations to test, describe, and solve problems. And a nice simple example here would be the bell jar with the balloons inside that represents the breathing system. So what you'll see here is we have the trachea coming down into the two lungs, which are the balloons. The bell jar acts as the rib cage, and then the rubber sheet down here acts as the diaphragm. And this is really useful because while it's not perfect, it allows us to kind of represent some of the important aspects of the lungs. So if we pull the diaphragm or the rubber sheet here down, it's going to cause the human lungs, or in this case, the balloons, to inflate. So when you think about this, it's actually really, really useful. So two balloons and rubber sheet does a really good job representing the human lungs and how they work. When you pull down the rubber sheet, the balloons will inflate, which is how we breathe in air. And this gives us a good understanding of the effects of the diaphragm in inhaling air. So as the diaphragm pulls down, this is increasing the volume, decreasing the air pressure, so air gets sucked into the balloons, and therefore they inflate. And if you think about this model, there is definite pros and cons, just like all models. So let's look at the pros first. So the pros, it represents the important impact made by diaphragm action to change air pressure and volume within the bell jar, which will then result in air being drawn into the balloons, just like what happens with the contractions of our diaphragm in our breathing system. The solid bell jar also gives us some sort of idea of how the ribs are there to protect the lungs, because the balloons are quite fragile, but once they're inside the glass bell jar, they're more protected, which is again what the ribs do for us. However, there are of course cons. So the model fails to represent the reality that the rib cage is flexible, so it also moves. And in reality, the diaphragm also recoils and moves back up to push air out of the lungs, and that doesn't actually happen here. You have to kind of help it along. So pros and cons, just like every single type of model. So as we move along here, we also need to be aware that models are clearly limited and they're not static. So models will change as our understanding of a concept improves over time. So if you think back to a really famous example of this, at one point in time, we thought that the Earth was the center of the universe, which was called the geocentric model. While over time, as technology and understanding improved, we came to learn that the sun is the center of our solar system, and the planets and the moons, etc., will orbit around the sun, and this is called the heliocentric model. So as our understanding improved, so too did our model. So a few questions to finish off here. What is a scientific model? Are scientific models static? And give an example of a type of model we use in science. Pause the video, jot down your answers, come back and I'll give you the right answers. Okay, so a scientific model is a representation of complex systems or phenomena that has been simplified to make it easier to understand. No, they change as our understanding of a concept changes, and examples would be diagrams, graphs, physical models, equations, simulations, all that sort of stuff.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.